All right. The next unit that we're going to do, the next several lessons, are all over polynomials, okay? Which basically, polynomials basically means many terms, okay? So you've got something with, an x to the fifth term, an x squared term. You could have an x to the fourth, third, a constant term. In this case, we only have an x to the fifth, x squared, and a constant term. But a polynomial is any function that all it has is these terms with these powers of our independent variable. Okay. So some characteristics you need to know whenever you see a polynomial is you need to be on the lookout for the leading coefficient. Okay, that's going to be your coefficient in front of your largest power of x, your largest power of your independent variable. But probably more important than that is the degree, the largest power of x here. So this would be the degree of your polynomial. Okay. Now, the degree does lots of things. It kind of determines what type of polynomial that we're dealing with. You're very accustomed to dealing with degree 2 polynomials. We call those quadratic. So if you had something like, I don't know, negative x squared plus 3x minus 7, okay? The leading coefficient would be -1. And the degree would be 2. So if you're dealing with a degree 2 polynomial, you'll know you're dealing with a parabola, either downward facing or upward facing. If you're dealing with a degree 3 polynomial, you know you're dealing with a cubic. Degree 5, that's quintic, okay? So it gives you kind of a gut feel for what type of polynomial that you're dealing with, okay? The other thing that the degree tells you is it tells you how many roots there are going to be in your polynomial. Now, what I mean by roots is all of these polynomials can be factored out in a form that looks like this. X minus blank. And how many of these that you have depends on the degree. So in this case, if it was a 5th degree polynomial, I should be able to come up with 5 different roots, which means we have up to 5 x-intercepts on our polynomial. If you've got degree 2, well, that cuts it down to only 2 roots here. Now, these roots could be positive, negative. They could be imaginary or complex. You could have a double root, something like this. Okay, but the degree of the polynomial tells you how many roots we're going to see like that. That's actually called the fundamental theorem of algebra, is that the degree tells you how many roots there's going to be. Now this a right here, if you multiply all these out, this will still be the leading coefficient, as long as you don't put any numbers in front of these x's here. Let me show you an example of that. So let's take a look. If we had something like this. So this, before I do anything, how many roots do I have? I have 3 roots. This is going to be a degree 3 polynomial. And my leading coefficient is going to be 2. If you don't understand why, let's go ahead and multiply this out and see what happens. So if I distribute my x here, this is x squared minus x. If I multiply by x plus 5, we have x to the third minus x squared plus 5x squared squared minus 5x. Combine this, we get 2. We get that. Then I distribute my 2. Oh, 8x squared minus 10x. All right. Now, take a look at this. So at the very beginning, I told you it was going to be degree 3 because we knew we were going to be multiplying an x by an x and then multiplying an x by another x. That's going to give us this guy. And since we're not multiplying those x's by any other coefficients in here, the leading coefficient is going to be this guy on the outside. Okay? So ideally, though, we really like to deal with a polynomial in this form right here. Because if we deal with it in this form, I know the leading coefficient, I know the degree, and I know all the x-intercepts. Well, how do I know the x-intercepts? The x-intercept is when y equals 0. And if y equals 0, that means either this guy, or this guy can equal 0. We learned that earlier in this section. Earlier this year, I mean. So my roots are x equals -5, x equals 1, and x equals 0. And it's really, really easy to see from this form. Okay, so here's your introduction to polynomials. If we wanted to get backwards, get to this from the other, we're going to have to factor. So, for instance, if they give you something like this, now this is fine, 5x squared plus 6x. Okay, we know we should be able to factor this out into 3 parts. So I've got a common x I'm going to take out. I know that 2 times 3 gives me 5. So my 3 roots wind up being 0, -2, and -3. Now, it won't always factor out into nice little numbers like this. It will on your homework. But in the real world, you might have to use quadratic formula. You might have to use other tools to get it factored out the way that you want. But we know from the fundamental theorem of algebra that this will always factor into these 3 pieces. You'll notice the leading coefficient is 1, and the degree is 1, 2, 3. So there you go.